Hey everyone, Professor Baldwin here. Today we have a function which is a quadratic and we're asked to answer a bunch of questions about it. Our function is f of x equals 2x squared plus 2x minus 4. And the first question is, does the graph of y equals f of x open upward or downward? Well, remember a quadratic is in the format ax squared plus bx plus c. The a value is what will tell us if it opens upward or downward. Since a here is positive, it's greater than 0, that tells us that this graph opens upward. And the second part of this question asks, is the graph wider, narrower, or the same as the graph of y equals x squared? Y equals x squared would be the parent function here. And again, we look at the value of a. And we already considered whether a was positive or negative, and positive told us it opened upward. So now we want to look at the absolute value of a. And since it's greater than 1, this tells us that our new graph is actually narrower than the parent function, x squared. Now part B. Part B wants us to find the axis of symmetry and the vertex. Well, the axis of symmetry is the equation of a vertical line that goes through the vertex. So let's start by finding the vertex. And the x value of our vertex is equal to negative b over 2a. And we know that b here is 2, so we have negative 2 over 2 times our a value, which is also 2. That gives us negative 2 over 4, which simplifies to negative 1/2. So the x value of our vertex is negative 1/2. And that x value also tells you the equation for the axis of symmetry. And that is x equals negative 1/2. So it's a vertical line at negative 1/2. Now we need the rest of the vertex, the y-coordinate. And y is found by substituting in the x value, which is negative 1/2, into our given equation. So we have 2 times negative 1/2 squared plus 2 times negative 1/2 minus 4. This first number is 2 times 1/4, and the second 2 times negative 1/2 is negative 1 and minus 4. 2 times 1/4 is actually 1/2, so we have 1/2 minus 1 minus 4, or 1/2 minus 5, and that goes to negative 4.5. So our vertex is the point negative 1/2, negative 4 1/2, or my math lab probably wants negative 9/2. So we have the axis of symmetry and we have the vertex. So let's see what question C asks. Find the discriminant and determine the number of x-intercepts. Well, the discriminant will always tell you how many x-intercepts you have. And remember, the discriminant is the radicand from your quadratic formula, or b squared minus 4ac. And b was 2. So we have 2 squared minus 4 times a, which was 2, times c, which was negative 4. So this is 4, and we have a positive 4 times 4 is 16 times 2, that's 32. So our discriminant has a value of 36. And since 36 is greater than 0, we know that we have two real number solutions. Now part D, find the y-intercept and any x-intercepts. Well, the y-intercept is probably the easiest here. Remember that a y-intercept is going to be the point 0 and then some value for y. So you're substituting in 0 every place there's an x in that given function. So that would be 2 times 0 squared plus 2 times 0 minus 4. Well, that simplifies to 0 plus 0 minus 4, or negative 4. So our y-intercept, remember it's a point, so it's the point 0, negative 4. Now, how about x-intercepts? X-intercepts are the solutions to that quadratic, 2x squared plus 2x minus 4 equals 0, right? It's the points when y is 0. Well, I see I have a GCF of 2, so I'm going to see if I can solve by factoring. And this factors to x squared plus x minus 2 equals 0. And sure, we can factor that polynomial. It factors to x plus 2 times x minus 1. So we have two possible solutions. We have x plus 2 equals 0, and we have x minus 1 equals 0. The first one, we subtract 2 from both sides, and we have an x-intercept of negative 2. Or, that's the point, negative 2, 0. In the second, you add 1 to both sides, and you get x equals 1. So the other x-intercept is the point 1, 0. Now we have 3 points from that. 1 point for the y-intercept and 2 points for the x-intercept. And part E is asking us to sketch a graph. So I would start with those intercepts. So our y-intercept is 0, negative 4. And then our x-intercepts are negative 2, 0, and 1, 0. Now, you also want to plot the vertex because that'll give you that axis of symmetry line. So it'll be easier to draw a more realistic quadratic. So our vertex was negative 1/2 and negative 4.5. So that would be right here. So remember, our axis of symmetry is this imaginary line that goes through that point. So if we connect these, we have the right side of our parabola, and then we can connect to get the left side of our parabola. So we have sketched a graph of y equals f of x. Remember, you should have at least 3 points. You may also have a fourth if your vertex is different than one of your other intercepts, but you should have your intercepts and a vertex that you can plot.